This is Charles. He's in love with his neighbor Emma.
Oh, Emma, if only I could find the perfect time to talk to you. But you never leave the house at a consistent time.
Well, Charles, I've got just the solution for you.
Who are you?
I am the divine orchestrator of the universe, the all-knowing, all-seeing narrator of your story. Basically, I'm God and I'm here to facilitate your plot development.
What?
Here, the probability that Emma leaves the house at a certain time can be described by this probability density function fx, where 0 represents 10 a.m. and 1 represents 2 p.m.
Whoa, thanks. This is amazing. The only problem is that I don't know how to do math.
I'm sure you can figure it out. Your love depends on it.
Okay, so God just told me that fx is a function that represents the possible times Emma leaves the house. From this information, I should be able to determine the average time she leaves in order to maximize my chances of meeting her. I know that to find the average or mean of a discrete random variable x, we simply need to multiply each value of the random variable by its probability and add the products. But instead of a discrete random variable, we have a continuous random variable. A continuous random variable x is one which can take an infinite number of possible values. The function f of x is a probability density function, where the value of f of x represents probability. In other words, the value of f of x is equivalent to p of x equals x. With discrete random variables, to find the mean, we multiply x with p of x equals x. So for continuous random variables, we multiply x with f of x. However, we have to be careful. F of x may represent probability, but it does not equal the probability that x will be a given value. As there are infinite potential values of x, the probability that x will be a certain value is effectively 0. Instead, we can only determine the probability that x will be within a certain range of values, and to do that, we have to find the area underneath the function via integration. So to find the mean of a continuous random variable, we have to integrate the product of x and f of x over the entire range of possible values. By doing this, we get the answer of 5/9 as our expected value. As in this case, 0 is 10 a.m. and 1 is 2 p.m., 5/9 corresponds with a time roughly around 12:10. Hi, Emma! Oh. She's not here. I found the mean, but it didn't work. Why didn't I see Emma?
Have you considered trying to find the median?
No. What's the median?
That's the middle number in the sorted list of numbers. Very roughly speaking, it is the point with the highest concentration of probability. Sometimes, when the possible set of values is highly skewed or there are significant outliers, the mean is not an accurate representation of the central tendency. In these cases, it is better to use the median.
So how do I find the median for a continuous random variable? By definition, the probability that x will be less than the median is equal to the probability that x will be greater than the median. As the total area of a probability density function is 1, the area to the left of the median is equal to 0.5. As we know that we can integrate f of x to find the area beneath the curve, we can just set an integral equal to 0.5 and solve for the median m. I see. So since the median is 0.575, this means that I should leave the house at 12:18 to see the love of my life.
Good luck, soldier.
Thanks, bro. Oh, hi! She's not here again. Why still haven't I found Emma? I'm certain I've done all my math right. So far, I've found the mean and median of fx, but maybe these values aren't the same as when Emma is most likely to leave the house. So how do I find when Emma is most likely to leave the house? I've got it. I can just find the mode. The mode represents the value or values of x that have the highest probability density within the distribution defined by fx. In other words, it's the peak of the probability distribution. To find this peak, we just have to determine the maximum value of f of x. And in order to find the maximum or minimum point of a function, we just have to differentiate fx to find the gradient function f prime x. And if the gradient of a function is equal to 0, then we know that there must be a maximum point. Therefore, we can just set f prime x equal to 0 and solve for x, and that should give us the mode of this continuous random variable. In this case, the mode was found to be 5/6, or around 1:20 p.m., quite different from both the mean and the median. Though the mean, median, and mode are all measures of central tendency, they fit some situations better than others. And in this one, well, you'll see.
And thus, these star-crossed lovers once separate lives in time, and it couldn't have been done without the knowledge you have now gained from continuous random variables